All right, we're going to talk about geometric sequences now. And the way I'm going to start that off is by first comparing that to an arithmetic sequence. If you remember in an arithmetic sequence, we had a common difference. So this would be an example of an arithmetic sequence. When we go from here to here, we added 2. From here to here, we added 2. From here to here, we added 2. So we had a common difference. We called it D, and it would be 2 in this case. Right? We came up with the formula for a to the nth. I'll use a lowercase a. It was whatever the first term was plus the common difference times n minus 1. That's just the arithmetic. But now we're talking about this idea of a geometric sequence. And it's similar, except you don't have a common difference, you have a common ratio. And for example, I'll show you 2 being one term, and then maybe 4, and then 8, and then 16, and then 32, on and on and on. Because if I go from here to here, I'm not adding 2. Well, you can see it as adding 2, that's fine. But if I try to add 2 here, I don't get to 8. So I'm really multiplying times 2, times 2, times 2, times 2. So I have this common ratio R of 2. All right, so the difference is one has a common difference, one has a common ratio. Both of them have a pattern. When we had that equation, that explicit formula for the arithmetic right here, we had a to the n, which is the nth term. That's going to be the same. We had the first term, a1. That's going to be the same. But instead of having an addition, because we're not adding 2, we are going to multiply that by the common ratio, R. Up here we added, here we're going to multiply because it's the common ratio. And instead of, well, up here, let me say, when you repeat something over and over and over, when you add something over and over and over, you multiply. Multiplication is repeated addition. When you multiply something over and over and over, multiply something times itself repeatedly, you actually have an exponent. That's what an exponent is. So instead of multiplying by n to the 1, we're going to raise it to n to the 1. So this is the explicit formula for a geometric sequence. It's similar if you compare the two. Instead of addition, there's multiplication. Instead of this being multiplied, you're raising it. Okay? So with that said, if I give you this one, I could say that my explicit formula, my first term is 2. My common ratio is 2. Now, I just can't write a 2 here because that looks like 22. So make sure you show there's multiplication in there. And then you raise that to the n minus 1. So for this example, this right here is just the explicit formula. Let me label that. And for this example, it would be this. Okay. Now, if I wanted to graph that, and this is taking it a little bit further, actually, let me first find the. So, for example, find the. I'm not going to say 10th term. I'll say third term because I don't want to do a lot of the math. No need here. So if I know that my explicit formula is this, then my third term is when n is equal to 3. This is very similar to when we did the arithmetic. So it's 2 times 2 to the 3 minus 1 because n is 3. So that's really equal to 2 times 2 to the second. And according to the order of operations, I need to do this part first, right? So it's 2 times 4, or 8. So the third term in this sequence is 8. Now, I knew that because I had the listing here. There it is. The third term is 8. All right, so very similar to the arithmetic, except we're dealing with common ratio. I'm going to see if I can very quickly graph it. Doesn't look like I'll be able to. Scratch that. I'll do one in the examples. All right.